Hello students, so in our previous class we have seen about the structure of atoms, that is different elements, how we can draw the Bohr atomic model. Next our topic is related to atomic numbers, mass numbers, isotopes and isobars. So before that we have to go through valency in a short way. So valency already we have explained in a previous class. Valency is meant by the combining capacity of an atom of an element. So in our previous class, that is in moles, how to calculate the moles, in that chapter valency have been described. So that is already available here. Usually the valence electrons means the electrons which are present in the outermost shell are called valence electrons. So normally according to the octet rule, we say that an atom has a capacity of holding 8 electrons in the outermost shell, except the first shell. So first shell it has got 2, remaining all it has got 8 electrons in the outermost. Now when this condition is fulfilled, then element is called to have octet configuration and is considered stable in nature. So stable means what? It will not react. Reactions will be very less. It will not lose or gain electrons or even share electrons to form other compounds. There are some elements like helium, neon, argon, etc. If you look at our previous one, helium has got its first shell complete. Neon has got a configuration 2, 8. Argon has got a configuration 2, 8, 8. So these are elements which are called as noble gases, and they are basically inert in nature. Inert in the sense they do not react. So this is a condition which all these elements has to follow. Whereas other elements, they have not got 8 electrons in their outermost shell. So what they will do? They will always try to gain, lose electrons. Now, how many electrons they have to gain or lose? That is actually what is called valency. The number of electrons lost or gained or shared by an atom to attain the octet configuration is called the combining capacity or the valency of the element. For example, if you look at uh, our elements which we have drawn in a previous class, that is say sodium, if I am drawing Na, the configuration is 2, 8, 1. Two, 8 and 1. So this one electron, actually if it removes, we will get octet configuration. So here what is the tendency for sodium? It is to lose one electron. So it will become Na plus 1. This is called valency. So how many electrons are present in the outermost shell will determine the valency. If you have 1, it will be plus 1. If you have 2, it will be plus 2. If you have 3, normally it will be plus 3. In case of 4, usually sharing takes place. Sharing of electrons will take place. If you have 5, normally it is minus 3. If you have 6, it will be minus 2. If you have 7, it will be minus 1. Because here it will be gaining. Example chlorine, which we have seen, 8, it will be 0. Okay, the valency will be 0. So this is shown in the table here, the valency of elements. You can see hydrogen is 1, helium will be 0, lithium will be 1. Look at the last electron and just write it, 7. For noble gases like helium, uh, neon and argon, you can see it will be 0. Argon, it will be 0. So here I have not mentioned the sign. You can also mention it without putting the sign. Plus or minus sign actually indicates whether it is losing or gaining. If plus means it will be losing, and if minus means it will be gaining. So atomic number and mass number we have not told in the earlier class, so that we will tell now. Atomic number is designated with the symbol Z, which means the number of protons, which will be equal to the number of electrons which is present in the nucleus in an atom. Okay, so generally when we write hydrogen 1 or sodium 11, the number which is shown at the bottom is the atomic number. Then what is mass number? Mass number is actually a sum. It is a sum of protons and neutrons. This proton and neutron together is called nucleons. Why? Because they are present in the nucleus of an atom. And this total sum is called mass number. Example, carbon, we are writing C612. So this 12 is the mass number. So it consists of 6 protons and 6 neutrons. Now aluminium, its mass number is 27. So 13 protons and 14 neutrons. 32, 16 protons and 16 neutrons. Usually it is shown as a symbol like this. The lower element determines the atomic number. The upper number is called the mass number. Now let us look at what is isotopes. They are the atoms of the same element having same atomic number but different mass number. For example, we can take hydrogen. So we will write it like this: hydrogen 1H1, 1H2 and 1H3. The elements are protium, deuterium and tritium. They are the other names. They are also sometimes referred to as P, D and T. But usually in a sample of hydrogen gas, you get 99% of hydrogen 1 only. That is protium only. So we usually write it as 1H1. Even carbon has got its isotopes C612 and C614. Chlorine has got its isotopes 17 chlorine 35 and then 17 chlorine 37. Now what is the specialty of them? If you look at their atomic number and mass number, they will have same protons, same electrons, but they have different neutrons. The neutrons number will be differing. Okay, so you can see here the example of hydrogen is shown. In the nucleus of hydrogen, you can see the first one proton is only there, and 1 minus 1, there is 0 neutron. Neutron is 0. Whereas in the second case, deuterium, there is 1 proton which is shown by yellow color, and 2 minus 1, 1 neutron. In the case of tritium, there is 1 proton and 3 minus 1, 2 neutrons. Okay, so the different number of neutrons will be coming for isotopes. Isotopes will have all the same chemical properties because they have same electrons. They have same chemical properties, but their masses will be different, and because of their difference in the number of neutrons. Now let us look at isobars. Isobars are atoms of different elements having different atomic number but same mass number. Two examples are given here: calcium and argon. You can see 20 calcium, 18 argon. 40 is the mass number of both of them. Same way iron and nickel, 26 iron, 27 nickel, but 58 is the mass number. These things are called isobars. So with that, we are closing this chapter. Thank you all of you.